Hello students. So today we are going to look at this chapter. We title it Maps and Scales, sometimes called Scales and Maps, but either case is actually a sub-chapter under the big idea of ratio and proportion. So we will actually look into more details with regards to ratio and proportion, but what we are dealing with is that this is a real-life application of the concept of proportionality, because when we deal with maps, there's a scale, especially when we say maps are the best maps are actually produced or drawn to scale. So having a scale that is accurate and proportion allow us to use the map properly, effectively. I mean, if you have a map that is not scaled correctly, then or is not drawn to scale, it's not a very useful map, right? So these are the handouts that I should have actually given to you in class, right? So the essential understanding, the essential questions, as well as the big ideas checklist, we will work on them in class. So I thought since it's a short chapter, so for the examples that's within this particular chapter, I'll just run through them through a video like this, so that you can follow along and complete the examples to gain the understanding. Then after that, if you have any questions, ask me in class. All right. So let's begin with the introduction. So we'll talk about scale drawing. So this is not just on maps, right? So sometimes we have buildings. You heard of things like blueprints. So civil engineers and architects, they use this a lot, and we need to have accurate scale drawing. Floor plans, right? Floor plans of events that you're planning, you also want them to be drawn to scale. So the explanation here is this: a map that is the same size as the area it represents is not very useful, of course, right? If you have a map of the school, for example, the map cannot be as big as a school. It doesn't make sense, right? So we scale down the measurement to make the map small enough to be conveniently carried around, or display on your TV screen, right, or your device, so that people can use it. So in order to represent this scale, we use a ratio, and this ratio is usually represented such as using the comparing of distances. So if I have a map, it will be the map distance to the actual distance, all right, or it could be the drawing length to the actual length. So there are different ways to represent them. But what are some of the standard ways that we represent them, right? So the standard ways that we represent them, okay, is these two. Let me highlight it for you. These are the two standard ways we represent them. So sometimes we represent them with units, sometimes we represent them without units. So when we represent them with units, of course, we express them in this manner, like 1 cm to 1 kilometer simply means 1 cm on the map is 1 kilometer in real life. Whereas if I just have a scale that is just numbers, it means that 1 cm is representing 100,000 cm in this case. Okay, so or 1 meter is 100,000 meters, or 1 inch if you are using a unitless scale, it means 100,000 inches, right? So that's how it works. Now sometimes we also represent them as in the form of a fraction. So you can see here there's this thing called the representative fraction. Sometimes we can also represent it as a fraction, instead of a ratio. It is acceptable depending on the context of the question, right? So in a nutshell, okay, if we represent them as a ratio or as a fraction, it does not have units. So I think we learned before when we were dealing with the chapter on ratio, we know that ratio in its final and simplest form should not contain any units. Okay, so this is called the representative fraction. So let's look at an example. So for example, I have a map, and the scale is 1 centimeter to 25 kilometer, and we want to express them in the form that is required. So what we really need to do, of course, is to first express this scale in the same units. Then after that, we can actually forgo the units. So what I can do is part A, right? We actually have 1 centimeter, and it's compared to 25 kilometer. So I want to make them the same unit. So 1 centimeter, 25 kilometer is 25,000 meters, and then 2 more zeros for centimeter. Okay, so there we go. The final form, the scale is 1:25,0,0,0,0. Okay, do count your number of zeros correctly. So this is part A. part B, representing as a fraction, we just have to write in a fraction form. So we are fine. Okay. Now example 2, this time around, they give us in terms of the fraction and want us to find the distance represented on the map for the following. Now usually on the map, if you use the SI units, we use centimeter because 1 meter on the map. Most maps are not even 1 meter large, right? So let's find it in centimeter. Okay. So what we can do here is we have no idea what the you can actual distance on the map is, but we know the actual. So we can actually write down the ratio in this way, right? If we have the actual versus the map, we know that 15000 is to 1, right? And of course, we can actually have it with units. So I put meters here because why? Over here is meters, right? So if we do that, then we can actually rewrite this as 15,000 meters is 1 centimeter on the map. No, sorry, 100 centimeter on the map, right? Then we scale it accordingly. So 15000 divided by 750, that will give us 20. So that means I need to actually divide by 20. So this is 750 meters, right? So just to illustrate, from here to here, I actually divide by 20, right? So 100 divided by 20, which gives us 5 centimeter, okay? But of course, this is just a ratio. The question asks us to find the distance on the map, so we need to answer the question correctly, to the question, right? So distance on map for 750 meters is 5 centimeter. There we go, right? Now we can also continue to find part B. Same scenario. Now actual to map. This time round, we know that 15000 meters represent 100. Right, come on, 100 centimeter. We already established that fact. We can, of course, rewrite this as kilometers, right? So this is 15 kilometers, which gives us 100 centimeter. So now I want 3.9 kilometers. So from 15 to 3.9, I actually need to, this is actually divide by 50 over 13, right? So you can just take 15 divided by 3.9 to actually get that value. So what happened? My 100 over there on the other side, I do the same thing. I get 26 centimeter, right? So 3.9 there we go. Okay, so answer to the question, of course, right? So part B, let's see, distance on map for 3.9 kilometers is 26 centimeter, right? Okay, let's move on. Okay, so now we come to the area, right? So of course, when we talk about scale, the default is that we are comparing length. So we are comparing length, not area. So area is different, right? So in order to find the ratio of the area, we need to actually square it. That's one way to do it. Or we just break it down into length times breadth. That works too. Okay, so there are actually two approaches to this. So let's see. Down here, we have a scale of a map is 1:35,000. So find the actual area in square kilometer, if it's 12 square centimeter. Okay, so what we do is first let's write down the scale. In this case, we are starting with a map. Compare it to a actual. Now this is part A. So I have 1:35,000. Okay, so since it's in centimeter, I can put down centimeter. And of course, the actual I want it in kilometer, right? So I need to convert this. So 1 centimeter, this one will be 350 meters, so 0.35 kilometers. Then to get the area, I can square it. So 1 square is 1. So, okay, come on, Apple Pencil. Right? And then we have 0.35 squared, which will give us 0.1225 square kilometer. So finally, I multiply by 12, which will give us 1.47 square kilometers, right? So of course, give context, answer the question. The answer is not the ratio. The answer is the actual area. So actual area is 1.47 square kilometers. Okay. Now part B, this time around, they give us the area actual, and then we are supposed to find the map. So I can write it in the other direction, actual to map. Okay, we have already established that 0.1225 square kilometer is represented by 1 square centimeter. Okay, so I can straight away just get 28 over here, right? So I'll take 28, divide by 0.1225 times 1, which will give us 228.57 centimeters square, right? So therefore, map area equals to 229 square centimeter, 3 significant figures. Okay, right, let's move on to the next example. Right, the next example, we are told that 2 centimeters represent 5 kilometers. Find the scale of the map in the form 1:R. We can do that, right? So what we have is a map to actual. This is 2 centimeters, corresponds to 5 kilometers over here. So I want to make them the same units. So this will be 5,000,000 centimeter. So 1 is to 250,000. Okay, there we go. Now part B, we want to write it in the form. So it is 1 over 250,000. Now part C, they says that the actual distance between two police stations are 6.6 centimeters on the map. Find the actual distance. So part C, what we can do is we have a map to actual, right? We are comparing length, so 2 centimeters is 5 represented by 5 kilometers, so 6.6 centimeter. Well, we just take 6.6 divided by 2 times 5, which gives us 16.5 kilometers. Now this is a ratio. The question asks for the actual distance, so please answer to the question. So actual distance is equals to 16.5 kilometers. Part D. The distance between two libraries is represented on the map. They are actually 9 kilometers. So now what happened is the actual to map. This time round, we can write it in the other direction. So 5 kilometers represented by 2 centimeters. So 9 kilometers, we have 9 divided by 5 times 2, which gives us 3.6. So therefore, distance on map equals 3.6 centimeter. Okay. Well, let's look at the next example now. Right. So now we have another one. This time around, they give us the scale of the map in the ratio form. So if the road is represented in 2.5 centimeter on the map, find the actual. So we again, the process is the same, right? So this time round, what happened? We start with map. Yes, map. Okay, let me write it properly. Map to actual. Okay, 1 is to 40,000, right? So we can add in the centimeter, that is fine. Okay, now the result we want in kilometers, so we got to change the units. So this will be 400 meters, so 0.4 kilometers, right? So 2.5 centimeter I just multiply by 2.5, so 2.5 times by 4 is 1 kilometer. So answer for part A, therefore, actual length is actually 1 kilometer. Okay, part B. Part B, this time round we're dealing with area, right? Take note, we're dealing with area. So we are given the actual first. So actual is to map, right? So we know that, well, we already know that 1 kilometer is actually 2.5 centimeter, right? So if we were to find it in terms of area, we square it. So 2.5 squared will give us 6.25 square centimeter. So 0.5 kilometer square will give us divided by 2, 3.125. There we go. So therefore, area on map equals 3.125 centimeter square, right? Okay, I hope you are getting the hang of it after a while, right? So the actual area of the pond, this time round, we have this square kilometer, right? It's represented on the map A. So now we have a map A. And then later we have a second map. Do we have a second map? We have a map B. But we deal with it one step at a time. Don't need to panic, right? So part A, we want to find the scale of map A, right? So map A, we have a map versus a actual, right? We may want to indicate that this is map A so that we don't get confused. We have 400 square cm is represented 16 kilometers, right? So to find the comparison in terms of length, we need to square root it. So square root of 400 is 20. And square root of 16 is 4. Okay, now we want them in the same units. So 20 centimeter, this will be 4, 1, 2, 3, 4, 5 centimeter. So now I divide by 20. 1 divide by 20 centimeter. So 400,000 divided by 20 will give us 20,000. Okay, done. So therefore, K equals to 20,000. Part B, the distance between two locations on map A is 8.6. Find the distance of the same two locations on map B. So what we need to do is we need to find the actual first, right? So map, actual. Now this is, we start from map A, right? So we have 20 cm is represented by 4 kilometer, which is fine, right? So let's see, 8.6 cm. So 8.6 divided by 20 times 4 will give us 1.72 kilometer. Right, double check again, 8.6 divided by 20 times 4. Okay, so that is the scale for map A. So the actual distance, right? The actual distance is this one, 1.72 kilometer. So that's what we want to find. So now we move on to map B, right? So map B, we have actual to map, right? You may want to divide it to make things clearer. This is map B. So what we have here is 0.4 kilometer represented by 1 cm, right? So therefore 1.72 kilometers is represented by, so 1.72 divided by 0.4 will give us 4.3 centimeter. Cool, right? So therefore distance equals 4.3 centimeter. Remember to write this statement because you cannot, this line over here is a ratio. The answer is not a ratio, the answer is the actual length. So this is your final answer. Okay, so be clear about that, right? So part C, they say state which map has a longer map distance. So the map distance of map A, let me highlight it so they can see, is 8.6 for the actual and 4.3, right? So it's quite obvious the winner is, in terms of the map length, map A, right? So part C, map A. Map A wins. Okay, it has a longer distance for these two locations. All good? Right, moving on. Oh, let's summarize, right? Okay, so a map scale, right? So some of this vocabulary, let's get it clear. A map scale is the ratio of a single unit of distance. Okay, that means it doesn't matter which unit. I mean, you apply units to both sides of the ratio, it works. Okay, and it's usually represented with either a ratio or a fraction. And when it comes to the areas, we need to actually square it. So when we talk about the scale is usually given with a comparison to the length. So if you're comparing area, do remember to actually square, and then if we are given the area, we need to square root it to get back the comparison of the length to compare the scales. Right, so with that, we actually run through all the examples. And then after that, if you have questions, after running through all these examples, do ask me in person in class, and I will explain to you, and hopefully you learn something. Okay, now this extension, let's talk about it in class. All right, have a nice day.